Okay, let's look at your square root method for solving quadratic equations. And in this video, we're going to look at answers that involve numbers that are perfect squares. In the next video, you will see an illustration on how to deal with numbers under the radical that are not perfect squares, just to make sure that you enter your answers correctly in case that comes about. But your square root method is a way of solving quadratic equations when you have a perfect square equal to some value. So in this case, I'm given just, probably the most basic looking square root method property equation, and it's x squared is 9. Now, to solve this, we do the opposite. So what we do is we take the square root of both sides. But anytime we take the square root of both sides in solving, we must include a plus and a minus because there are two solutions. So we have to include the positive and negative values. So you could say x is 3 or negative 3. Okay, so that's kind of just, if you're giving just an x squared. Now, if you're giving a quantity squared equal to a value, let me see if I can turn this light on if that helps us, then this is still a perfect square of one term. If we squared it out and subtracted, we could still factor, use the quadratic formula, but this is going to save us some time. So I can still do the same process. I take the square root of both sides, remembering to put the plus and minus in front of the 16. Now the square just cancels out the square root, so that leaves me x minus 1, and I simplify my radical to get plus or minus 4. Now that's all good, but I still have not solved for x. So what I do is now I create my two equations, because again we have two solutions. So x minus 1 is 4, or x minus 1 is negative 4. And then I solve. I add 1 to get x is 5. I add 1 to get x is negative 3. Okay, so those are solutions involving, values that have perfect squares on the right side of the equation. Like I said, the next example is going to show you how to simplify a radical, but let me do one that involves a radical that you cannot simplify. So let's say we have x plus 2 squared equals 7. So I still take the square root of both sides, making sure I have my plus minus. These cancel each other out, so I get x plus 2 is plus or minus the square root of 7. And I can, at this point, create my two equations. X plus 2 is the square root of 7, or x plus 2 is minus the square root of 7. And then what we can do is we can probably subtract my 2 and list it first. So this is a form of the quadratic formula. I can't do anything with the square root of 7. Most of the time my math lab is not going to have you make decimals out of these. They just want you to leave them in square root form. Sometimes they may accept, I don't know, it's always changing, plus or minus the square root of 7. So there's various ways that you can illustrate these answers. It depends, what they're looking for. So anyway, so that's your square root method. Like I said, the next video will show you how to break down a square root that may be able to be simplified.